Good morning, everyone. Good afternoon. Good afternoon, everyone. I'm Ryosuke Yamaki at Taniguchi Labo at Richmond University. I'm a first year PhD student. And today I'm going to talk about holographic video. Today I'm going to talk about my research about holographic CCG parsing. Very shortly and briefly because everyone gets hungry now. So this research is conducted on the collaboration with Daichi Mochihashi, Dr. Daichi Mochihashi, computational linguistics at the Institute of Statistical Mathematics. The outline is about the brief introduction about syntactic parsing firstly, and I use our model of holographic CCG. And this is now I'm trying to use holographic CCG plus image generation model. And finally, I will talk about a possible application in this Qualia Structure project. And firstly, I will talk about what is syntactic parsing. Syntactic parsing is a kind of a traditional field in natural language processing, and it treats the syntactic ambiguity of natural language. Let's consider this sentence: a man looks at the girl with binoculars. This sentence has at least two interpretations. The first interpretation here is girl has binoculars. This means with binoculars, this prepositional phrase modify a girl, this noun phrase a girl. And another interpretation is man has binoculars. And in this case, with binoculars modifies this looks, verb phrase, modifies verb phrase looks. And each interpretation is corresponding to this kind of tree structure. This is called a constituency tree or constituency structure. And yes, but in this case, there's not enough information to distinguish which structure is more plausible, because a man or a girl is two general term, so there is no information enough to distinguish this structure. But if this time we want to consider about if the subject of this sentence, a stalker, a man changed to a stalker. Now there is more information rather than a man, because a stalker is a kind of strange person. So in this case, the right-hand side interpretation, because which means stalker has binoculars, is more plausible than the left-hand side one. In syntactic parsing, we want to evaluate this kind of in syntactic parsing, we want to search for possible syntactic structure from the input sentence and evaluate which kind of which structure is most plausible. And next is the combinatory category grammar CCG. The CCG is one of the grammar rules used for syntactic parsing. And yeah, I want to explain detail, but CCG is constructed on the basic grammar, basic categories. S is sentence, N noun, NP noun phrase, PP prepositional phrase, something like basic categories, and the combination version of these basic categories. The combination is conducted by connecting these basic categories by slash or backslash. And this NP slash N means determinant. This means a spoon is a noun phrase. In the a spoon, is a determinant. And NP slash N means the kind of word that take noun to the right-hand side of it, then and become NP. And in CCG, this kind of combination of basic categories and CCG describe the kind of formulate a syntactic structure. And from now I'm going to describe about holographic CCG. And one of the motivation of holographic CCG is composing syntactic phrase level representation. In 2013, the Word to Beck or the more recently Bart are trying to compose word level syntax, word level some kind of distributed representation. But in contrast, some kind of phrase level representation is not more focused on recently. So in holographic CCG, we are focused on composing phrase level representation, and in compositional vector grammar related study, compositional vector grammar trying to do something like that, but they need large number of training parameter for train the model, and it's difficult to train the model. So in holographic CCG, we try to compose syntactically rich phrase level representation while maintaining the training efficiency. And then we focus on the holographic embedding. It's an embedding method of knowledge graph into vector space for statistical modeling. And in holographic embeddings, they recursively compose vector by circular correlation operation to capture the dependency between entities in knowledge graph. And we focus on the similarity of knowledge graph and the phrase structure, which both need to capture dependencies between components. This equation is a circular correlation. We call this operation as a holographic operation. Now this is the holographic outline of holographic CCG. Holographic CCG is a method for formulating CCG as a recursive operation of between distributed representation of word representation in the vector space. For example, this is an example of my sister loves to eat. For example, in this example, the verb phrase loves to eat is composed by V23, V3, 4, V4, 5, like in recursive manner. And this is the model structure of HoloCCG. And firstly, the sentence is encoded into the distributed representation by deep contextualized encoder like a BART or Robert or something like that. And V01 corresponding to my, and V1 to sister, V23 loves, V3 to V45 to eat, something like that. And then this kind of word level representation is recursively composed into the phrase level representation. And this phrase level representation depends on each word level representation. And then feeding these kind of phrase level and word level representation into the feed-forward neural network and predict CCG categories and CCG categories. And today I will skip about a specific experiment result, but today I will show this kind of figure. This week I saw a lot of embedding space of color in Korea experiment, but this is the embedding space of the holographic CCGs, word level representation and phrase level representation. And this is example of the sentence: investors continue to pour cash into money fund. And here is the cluster of one, and each different color point correspond to each different CCG category.
So so all of this is coming from one sentence?
Not coming from one sentence. All of the data set, and if we pick up one point of the one point from the group of the sentence, that can be drawn like the start point of the other.
I see. So it's like this is a structure of the sentence.
Yeah. And in the embedding space of the color, there's maybe no operation between the point. But in this slide, embedding space, there's an operation in the embedding space. So for example, this is a money is a vector from here, and the fund here, and the money fund noun-phrase become here. These vectors and this vector compose into the noun-phrase vector here. And this kind of operation is conducted recursively. And finally, goes to the sentence vector here, the final root level representation. And this is the more recent work I'm conducting, holographic CCG plus image generation model. And maybe everyone knows about the recent text-to-image generation model like Stable Diffusion or Midjourney demonstrate very high quality and generate high quality image. But there's one limitation I know. It's difficult to control output for sentence which has a syntactic ambiguity. For example, an elephant and a bird flying. There are two interpretations. One is elephant and a bird both flying, or only a bird flying. But if we consider the common sense, elephant never flying. But if we consider the Dumbo in picture, and the elephant can fly, and if we want to generate the elephant that is flying with bird, maybe the text to image model cannot generate some kind of and this is useful for other text to image generation model and as an application, and it is also interesting for from the perspective of principle of compositionality in this. And for this target, now I'm trying to integrate holographic CCG into text-to-image model by incorporating the distributed representation generated by Holo CCG into a text-to-image model. And this is the model as I analyst. Finally, I want to look at the possible application. And holographic CCG latent space is composed by not only word level but also phrase level syntactic representation. This is one of the characteristics of Holo CCG. And this Holo CCG can bridge discrete language structure, syntactic trees, and a continuous high-dimensional vector space. And also can serve as a bridge between language and other modalities through its distributed representation. And distributed Holo CCG representation contains both syntactic side and semantic side information. And this can be served as a bridge between language to image, or language to color, or language to some kind of observation for human. Maybe more ideas come from language sensei. This is my presentation for listening.
Thank you very much.